So let's look at the hardware that actually does addition of bits. Okay, so let's just start with this. I have 2 bits that I'm adding, so I have 2 inputs. Okay, and unless you have 2 outputs, because I need the sum of those 2 inputs and also the carry bit. Okay, so it might look like this. Okay, if I have 0 and 0 and I have 2 inputs, there's only 4 possibilities. Then the sum is 0. If I have 0 and 1, the sum is 1. If I have 1 and 0, the sum is 1. And if I have 1 and 1, the sum is 0. Okay, I'm just looking at the sum part of the output. Okay, and as I look at this function, I go, hey, that looks a lot like OR. Okay, in fact, the only difference between this and OR is right here, right? Which OR will give me 1, and this actually gives me 0. Okay, this actually corresponds really closely to what we humans mean when we use the word OR in natural language, right? Because this or that in natural language means this, that, but not both, right? So yeah, this is actually that, and we call it exclusive OR, right? Exclusive OR is the logical name for this particular connective. Right? All right, so I need exclusive OR. Right? How about the carry? Well, if I have 0 and 0, the carry is 0. If I have 0 and 1, the carry is 0. If I have 1 and 0, the carry is 0. If I have 1 and 1, the carry is 1. I hope you recognize that function. That's just the AND function, right? If both are 1s, then it's 1, otherwise it's 0. Okay, so this is actually the circuit that we have in mind, okay? Right here, these are the inputs, okay? And this is the circuit notation for AND, okay? So if X and Y are both true, then we set the carry bit to true. Otherwise, we set the carry bit to false. These are, of course, the outputs. This is the carry, and this is the sum. Okay. Now, the sum is exclusive OR, and this is the symbol for exclusive OR. So yeah, that's it. Okay, that's the circuit that actually adds 2 bits. Okay, it's called a half adder. Okay, as opposed to a full adder, right? And the reason that it's half is because it produces a carry bit, but it doesn't do anything with a carry bit coming into it. Okay, so we need to deal with that. We need to actually fix what happens when a carry bit is coming in, and that'll make it a full adder. So here's our idea. The full adder takes 2 bits and a carry bit, okay, and produces 1 sum and the carry bit, okay. And the way that we actually build it is by using a couple of half adders, right? Because here's what we want. Okay, if I'm adding 0 and 0, okay, then I'm sorry, 0 and 0, and I have a carry bit of 0, then I just get basically what a half adder returns, right? So right here, this is just the output of a half adder. Okay. Otherwise, then I want to add 1 to that, okay? And I have to be consistent with that. So 1 plus 0 plus 0, that's just a 1. Sum is 1, no carry. 1 plus 0 plus 1, sum is 0, and a carry bit of 1, and so on. Okay, so here's what we actually do the circuit. We take X and Y, and we add those using a half adder, right? There's no sum. And then I have a carry bit, okay, and I have a sum. These are intermediate. Okay, so then I take the carry in and the sum and add those. Okay, if I add those, right, well, that's actually going to be the sum output. Okay, because that's A plus B plus C, so to speak, or X plus Y plus C. Okay, all right, so now I need to figure out what the carry bit is. Okay, and it turns out that the carry bit, well, if I had a carry bit from the original sum, right, you know, it means that I added 1 and 1, then I need a carry bit in the output, right? But if I have a carry bit in the final one, then I need a 1 in the output. So actually what I do is I OR those, okay? Because if either one of those 2 half adders ever gives me a carry bit, then I'm going to have a carry bit into the output. And if you think about it, that makes sense, because a carry bit means that the result is 2 or larger. And if I get 2 or larger in the first step or in the second step, it doesn't matter, right? The answer is going to be 2 or larger. That's what the carry bit is. Okay, so this is my circuit for doing adding a bit, right? I should say 2 bits and the incoming carry.